Alright everyone, last page of this handout, so let's start with number 5. So if we're looking at this, it's asked that the basketball initially travels at 3 meters per second for 3 seconds. Alright? And that then gives us exactly what this is. That tells us, or it helps us figure out the second portion of it once we get to that point. So it says, describe the motion of the ball after t equals 3 seconds. Okay? So in order to do that, we need to figure out after those 3 seconds, does the ball go in a positive or negative direction? So if we're looking here, this line right here is actually below 0, so we know it's actually at -1. So we'll say the ball travels at, or in the negative direction at 1 meter per second. Okay. So then you can say in the first section, which is when we're talking about the 3, after 3 seconds, at 3 meters per second, the ball traveled 9 meters. And then in the second, the ball is going at a -1 meters per second, or it's going in that negative direction over 1, 2, 3, 4 whole seconds. Okay? And that would then equal 4 meters traveled. Okay? Somewhat simple there. So now if we're looking at a motion map, so to figure out how to explain this, well, we know how fast it's going in a certain amount of time, so that's enough for us to then figure out how far to represent its motion. So always number your axes when you're doing it. It's going to help a lot, I promise you. So we're starting at 0 seconds and at 0 meters. But for the first start, we know that every second we travel 3 meters, because that's what our initial prompt says. So I'm going to draw my arrow to approximately 3 meters. Okay? That's going to represent 1 second. Then I'm going to need to travel an additional 3 meters every second. Okay? So I'm going to draw another arrow. And then I should be up to 6. And then my third second is 1, 2, 3 seconds. I should be at 9. So I'll draw my arrow. Okay? Now, to make sure we're including this other portion of our velocity versus time graph, we need to show that over a certain amount of time, how far do we travel? Now, because we're actually closer to 0 here, we know that we're going slower. Whereas it's higher up, that means we're going faster. So our arrows then are going to be smaller. So we're going to start at 9, and then we travel at just 1 meter per second in the negative direction. So then we'll be at 8, and then we'll be at 7. You have to visualize it, it'll be in the middle here. Then we'll be at 6, and then we will be at 5, and that is where we will end because we only traveled for 4 seconds. So start, end. Okay? Now on your own, I want you to try and draw a position versus time graph with now understanding part B since I did it for you. Okay? I'm going to move on to the next problem. That is a race car. So a race car speeds at a speed, reaches a speed of 95 meters per second after it is 450 meters past the starting line. If the car travels at a constant speed of 95 meters per second for the next 12.5 seconds, how far will the car be from the starting line? Now I know this is a little bit worrisome, it's a lot of words and vocabulary, it kind of gets confusing, but all you have to do is break down the components that are given, okay? So we wrote this equation down in class, and this is what's going to help us really figure out this problem. If you don't remember this equation, go back to your notes. So it says that the final position is equal to the average velocity times time plus wherever we started. So all we're going to do is we're just going to plug in this information based on what we have up above. So we know that 95 meters per second, that's our velocity. We're traveling at that constant speed. Time is right here. So it says for the next 12.5 seconds. Okay, so we're good there, we know those. And then, where did we start for that racetrack? Well, we started actually 450 meters past that starting line. It's almost as if we were cheating. Okay? So now all we do is plug in. So our average speed is, we set 95 meters per second. And they said after the next 12.5 seconds, plus wherever we started, we're actually being a little bit ahead. We have to cheat just a little bit. Plus 450 meters. If you add that all together, after multiplying the first two, you're going to get 1188 meters plus 450 meters equals 1,050 meters. Okay, so again, remember, whenever you're given a problem that seems really complicated, just figure out what you know and label it, and that will help you figure out how you can move forward in the problem. Okay. Now, this last problem, I'll do a portion of it, but I want you to figure out how to do this based upon knowing the differences in average speed, which really talks about a total distance versus the average speed we're talking about at distance. So it says Sally travels by car from one city to another. She drives for 0.5 hours to half an hour at 80 kilometers per hour, and at quarter of an hour, 0.25 hours at 105 kilometers per hour. Okay? So the total distance, really, that's just the sum of what we're trying to figure out. So 80 So 80 kilometers times 0.5 hours, or 80 kilometers per hour, so 10.5 hours. Those hours cancel, you get 40 kilometers. Okay, so she traveled 40 kilometers plus 105 kilometers per hour times 0.25 hours. I'll do that on my calculator really quickly. That is 26.25 kilometers plus 40. That's equal to 66.25. So overall, that is her total distance that she traveled. Okay? Now her average speed is just a little bit different. It's taking however long she went initially, and then at the final point, figuring out what was her constant speed if we were to average those things together. Okay? So all we have to do is figure out her changing position over however long it took her overall. Okay? So all we have to do is take our initial 80 kilometers per hour, which we said in point per values, that's just going to be 40 kilometers, plus our 26.25 kilometers over however long it took her total. So, in hours, it only took her 0.75 hours. Okay? Do that calculation. That will give you the average speed. Combining both legs of the distance or how her car traveled over the total amount of time, that's going to give you her average speed. Okay. I'm going to move on to the velocity calculations.